Okay, so here we'll go through the solutions for paper 2, and on this paper the calculator was allowed for this paper. So we've got question 1. Here is a linear sequence. It's 5, 13, 21, 29. Now linear sequence meaning that there's a common difference between the terms. Circle the expression for the nth term of the sequence. Okay, so here I can see that the sequence is going up in 8. Now if it goes up in 8, that's similar to the 8 times table, which goes up in 8. So there'll be an 8n there, okay, and there's 8n here. So it can't be the first one, it can't be the second one, it's one of these two. Now the sequence 8n is just the 8 times table. That'll be 8, 16, 24, and so on. 8n take away 3, well the first term here would be 8 times 1, which is 8, take away 3 is 5, and we can see that there's a 5 there, so it's clearly this one. Now question number 2, we have circle the fraction that is equivalent to 0.05%. Now you should have an idea of which one it is, and you should know that 5% is actually 1 over 20. Okay, so it looks like it's going to be one of these two. Also you should know that 0.05% is the same as 0.05 over 100. Okay, and then if you make that into a normal fraction, we're going to have 5 over 10,000. Okay, so 5 over 10,000 there. Now if I was to divide the top by 5, I get 1. 10,000 divided by 5 is 2,000, so it's going to be 1 over 2,000. Here we have a straight line has equation y equals 6 take away 2x. Circle the gradient of the line. Now you might be familiar with the format y equals mx plus c, where m is the gradient and c is the y-intercept. Okay, if I was to put it in this format, what it would look like is our equation would be y equals negative 2x plus 6. Okay, and it's asking for the gradient. Now the gradient is where the m is, so it's negative 2 for us. It's going to be this. Okay, so question 4 is y is directly proportional to x and k is a constant. Circle the correct equation. Now when y is directly proportional to x, that means there is an equation y equals k times x, which is this one. Question number 5. There are between 25 and 35 students in a class. So between 25 and 35. The ratio of boys to girls is 4 to 7. How many students are in the class? Now here we have a ratio that has 11 parts when it's simplified, because 4 add 7 is 11. Now so we need to think about multiples of 11 and multiples of 11 that are between 25 and 35. Okay, so multiples of 11 that are between 25 and 35. Let's actually write 4 add 7 first. 4 add 7 is 11. Okay, and then we know we have 11, 22, 33, and the next one will be 44. And so only 33 is between 25 and 35 of the multiples of 11. So there must be 33 students in the class. Okay, so question 6 is to solve an inequality. Okay, here we're going to need 2 steps for this. We're going to need to multiply by 2 on both sides and then divide by 3. Okay, so when I multiply both sides by 2, I get 3x is less than or equal to 18. Divide both sides by 3, I'm going to get x is less than or equal to 6. So x is less than or equal to 6. And again, I have another inequality here to solve. Okay, and this time I've got brackets. I might want to multiply that out first. So I'm going to have 4x plus 8 is more than 12. Okay, some of you might think actually it's easier to divide by 4 on both sides first. Okay, doesn't matter which way around you do it, both ways will give you the same answer. Take away 8 from both sides, you're going to get 4x is more than 4, and divide both sides by 4, you will get x is more than 1. Okay, so question 6c now is represent the solution set that satisfies both answers to part A and part B on the number line. So part A was x is less than or equal to 6, and less than or equal to we represent with a full coloured in dot, and part B was x is more than 1. Okay, and this is the open circle that we use. So open circle at 1, a closed circle at 6, and we draw a line to show that it's all the numbers in between 1 and 6. Okay, so question number 7 says this formula works out the tax you pay. So t is equal to 0.2 times e take away 10,600. T is the tax you pay in pounds. E is the amount you earn in pounds. Okay, and here they've told us that Alison pays £5,200 tax. Work out the amount that she earns. Now £5,200 tax. That means I can use £5,200 here, and I'll have an equation that I can solve, where I can solve the equation for E, rearrange everything, make E the subject, and I'll get the amount for E. So let's write £5,200 is equal to 0.2 bracket E take away 10,600. Okay, so I might want to divide by 0.2 on both sides, and I might want to use a calculator for that. So 5200. So 5,200 divided by 0.2 is 26,000, and that's equal to the amount that she earns, take away 10,600. Now if I was to add 10,600 to both sides, I will get the amount that she earns. So 26,000 add 10,600 is 36,600. So that is the amount that she earns. Okay, so question number 8 now. Solve x squared equals 30.25. So I need to square root both sides, but you must remember when you square root a number on a calculator, the calculator only gives one value, but we need to say that there is a negative value that's also possible. So it's going to be plus and minus square root of 30.25. Okay, and that is 5.5. So it's going to be x is equal to plus or minus 5.5. Okay, so question number 9 says, here are two piles of the same type of paper. Each sheet of paper, so one sheet of paper is this thickness, okay, in centimeters. The taller pile is 10.5 centimeters high. So I can actually find how many sheets of paper there are if I was to take this and divide it by that. And they're both in centimeters, so that would work for us. Height of the taller pile. Here's a ratio. Height of the taller pile to the height of the shorter pile is 3 to 2. So it's 3 to 2 here. Work out the number of sheets of paper in the shorter pile. Okay, so instead of finding how many sheets of paper there are here, let's find how high this is. Okay, so to find that, we can take this, we can divide it by 3 and times it by 2. Okay, or we can think of it like to get from 2 to 3, you times by 1.5. So to get from 3 to 2, you would have to divide by 1.5. So if I take this and divide by 1.5, I'll get the height here. So I'm going to write 10.5, divide that by 1.5, and I'll use a calculator for that. Okay, that is 7. Now, this is 7 centimeters high. Let's write that in. So this is 7 centimeters. Now I can find, the question was work out the number of sheets of paper in the shorter pile. So I can find that by doing 7 divided by this thickness here. So we've got 7 divided by 7 over 1000. Now this is actually quite easy to do without a calculator. This is going to be 7 times 1000 over 7. And you must remember that this 7 is really the same as 7 over 1. Okay, so I can write that. And then these 7s will cancel out. Okay, and I'll have a 1 left there and a 1 left there. And then that at the end is just 1000. Okay, so what we actually worked out was we did 7 centimeters divided by this thickness here. So that tells me there's 1000 sheets of paper. Okay, so question 10 is, here are 4 triangles. So we've got 4 triangles here. And the question is, which 2 triangles are congruent? Circle your answers. So we've got the 30 degrees, okay, in each triangle, and we've got the 5 centimeters and 3 centimeters. Now we need to look at where the 5 centimeters and 3 centimeters is relative to the 30 degrees. And I can already see that this 30 degrees is in between the 5 and the 3 here, and it's also in between the 5 and the 3 here. If I was to take this triangle and I put it here, it would just look like a reflection on a line, and therefore they are the same size and then the same shape as well, and they're exactly the same triangle. Okay, so it's B and C which are congruent. And if I look at A and D, you can see that the 30 degrees is being subtended by the 3 centimeters here. So the 3 centimeters is subtending 30 degrees there, and the 30 degrees here is being subtended by the 5 centimeters. Okay, so clearly these are not congruent either. Okay, or they're very different triangles here. So it's going to be B and C. Question B says, circle the reason for your answer to part A. We should be familiar with these. When we learn about congruent triangles, these are some rules that we can use to say that that triangles are congruent. In this case, we've got a side and then an angle and then side. Same thing here, side, angle and side. Okay, so side, angle, side is this one here. Okay, so question 11, we have describe fully the single transformation that maps triangle A to triangle B. So triangle A to triangle B. And we can see that it's gone smaller. If I look at this length here, we've got 3 there and we've got 1 there. So if it's got smaller, it is an enlargement. Okay, whether it gets bigger or smaller, we call it an enlargement. And this time we can see that the scale factor is going to be a fraction, because we went from a length of 3 to a third of that, which is 1. Okay, and if you look here, we've got 1, 2, 3, 4, 5, 6, and 6 divided by 3 is 2. Okay, so it's an enlargement by scale factor a third. So enlargement by scale factor 1/3. Okay, when we say an enlargement, because it's asking us to describe fully, we do need to give a center of origin or center of enlargement. Sorry. The best way to do that is to draw a straight line from this corner to the corresponding corner there. You can actually see it's going through like that. Okay, and then a straight line that way and a straight line there, and see where they meet. In this case, I can see that this is 1 away there and then 2 up, and I can see that it was 3 and 6 up. Okay, so actually it works perfectly when I use the point 0, 0. So 1 and 2, then you've got 3 and 6. Okay, so the best way probably is to draw lines, and you will see that the lines come through the origin. Okay, otherwise you can sort of count it out like that. Okay, and try different points. If I was to choose this point, it wouldn't work. So I've got 1 and 1, then I'd have to multiply that by 3. 1, 2, 3, 1, 2, 3, but this point is not here. Okay, but with this one it worked out quite nicely. Okay, so with center, with center 0, 0. Okay, so question 12, we have volume of a sphere equals 4/3 pi r cubed, where r is the radius. Work out the volume of a sphere of radius 8. Okay, so very easy question. You just put the 8 in here and you work that out. So, and you can put that in your calculator. So we've got 4/3 times pi times 8 cubed. I'll put that in my calculator. Okay, and that gives, this is equal to 2144.66 to 2 decimal places. Okay, so 2144.66, and that's my approximation there. Question 12b now. 3 spheres of radius 8 centimeters are packed tightly into a cuboid as shown. Okay, so these are the same spheres that we were working with there. The radius is 8 centimeters. Okay, and it's packed tightly here. Okay, so you can see that it's touching there, it's touching there, and it's touching at the top and at the bottom. Work out the volume of the cuboid. Okay, we can't see how it goes this way, but we've been told that there are only 3 spheres there, so it must be touching on this end and on that end. Okay, so if we think about that, we've got the radius is 8, they're saying, so each length like that would be 16 centimeters. Okay, double the radius. So if I said 3 times 16, okay, that gives me the length going this way. I know that going up would be 8, and going this way would also be, not 8, sorry, it will be 16. Okay, so this would be 16, because it's not the radius, it's the diameter we're looking for, and 16 here as well. Okay, so 3 times 16 is 48, and so that's 48. So volume of a cuboid is just 48 here times the 16 times the 16. So if I write 48 times 16 times 16, and that gives 12,288. Okay, so question 13, it says, in this question, all lengths are in centimeters, and what we have here is a triangle, and the lengths are given in algebraic expressions. And here it says, given that something, and then show that. Okay, so here we need to prove. Okay, so given AB to BC, so AB is here, and BC is here. So AB to BC is 1 to 2. Therefore, if I take AB and times it by 2, it should give me this, okay? And you can see that if I was to write that in algebra, it wouldn't look like that, okay? But what we need to do is we need to make an equation, and then maybe solve for x. And it says show that this, okay? So we can't assume this, and we just need to show that this is true when this is true, okay? So we said that if I was to take AB and times it by 2, I will get this. Also, this is actually a really important skill. If I was to have this one, so if I was to write 3 to 4, this is not part of the answer, I don't think. So 3 to 4, to go forward from 3 to 4, you need to do times by, so we need to divide by 3 and times by 4. That's the same as saying divide by 3 times by 4. It's timesing by 4 over 3. Okay, so this is something that we might use later. Then we've got, okay, so we've got this one. This one will be times by 2. Going back will be divide by 2. So let's do that. So we got AB is 3x take away 9. And if I was to times that by 2, and that looks like this, times this by 2, it gives me what BC is, which is 5x take away 11. Okay. Now what I have here is an equation with x as the unknown, and I can solve it. So this is going to be 6x take away 18, which is equal to 5x take away 11. I'm going to take away 5x from both sides, and I'm going to add 18 to both sides. That will leave me with x is equal to 7 here. So if x equals 7, now actually I can find what the lengths are in values. Okay, so I can find the length. There will be 3 times 7, which is 21. Take away 9 is 12. We can find this one, and we can find this one. And it says show that AC to BC is 3 to 4. So AC and BC are here. So if I was to find the length here and find the length here, it should be the same ratio as 3 to 4. Okay, so the length AC would be 2 times 7. So 2 times 7 add 4. That will give me 14 add 4, which is 18. And the length BC, so BC is the other one that I need, that's going to be 5 times 7 take away 11. So we're going to have 5 times 7 take away 11. 5 times 7 is 35, take away 11 is 24. Okay, so this was AC and this was BC. Now if I was to write that in a ratio now, if I said 18 to 24, okay, this should be the same ratio as 3 to 4. So I can divide both of these by 6. So if I divide 18 by 6, I get 3. And if I divide 24 by 6, I get 4. Okay, so it is the same ratio as 3 to 4. So that's now proven. Okay, so question 14 is, a menu has a choice of 3 starters, 5 main courses, and 4 desserts. How many different choices of a 3-course meal are possible? Circle your answer. So 3 possible starters. For each of those 3, so each of those 3, we've got 5 different main courses we can choose. And for each of these 15 different combinations of starters and main courses, we've got 4 different desserts. So times that by 4. Okay, and that will give us 3 times 20, which is 60. Okay, so it's 60. Question 15. A triangle has vertices, so 3 vertices here, A, B, and C. The triangle is reflected. Points A and C do not move. Circle the equation of the line of reflection. Now, it will be useful to maybe draw a sketch and see it. Okay, so in maths, anytime you can draw a picture of what's happening, is going to be useful. So I've got point A is 1, 2, so maybe about here. Point B is 3, 4, so maybe around there. And point C is 6, 1. So 6 and 1, and it will be in line with point A. So I can see that it's in line here. The y values are the same here. So we've got 1 there. This is A, this was B, and this is C. So they're telling us that the points A and C, they did not move, and it's been reflected. Therefore, the B came around here. So the line of reflection must go along here, okay, which is y equals 1, which is here. Okay, so question number 16 says the area of a right-angled isosceles triangle is 4 centimeters squared. Okay, and we've got a right-angled isosceles triangle here. Work out the perimeter of the triangle in centimeters. So we need to find the lengths, okay, and we need to give our answer in third form. Now, we need to know something about right-angled isosceles triangles, okay? We need to know that there is such a triangle that we can have that's right-angled, okay? Now, if it's isosceles, these angles must be 45, okay? Both have to be 45 because they both need to be equal. So I can have 45 there and 45 there as well. And suppose the lengths were 1 here and 1 there because it's isosceles. The longer side has to be square root of 2 using Pythagoras' theorem. Now, this triangle here is an enlargement of that triangle. Okay, so that's what I'm going to be thinking about when I'm trying to do this question. Now, in our case, we can see that it won't be this triangle because the area of this triangle will be 1 times 1 and then half of that, which is 0.5. Okay, so it can't be this one. It's different one. So we can say that we don't know what the lengths are, but they're the same on these sides. So if I was to take x and times it by x again, which is x squared, and then also half of that, so divide that by 2, that gives me 4. Okay, so x squared over 2 gives me 4. I can use that to find x now. So times both sides by 2, I'm going to get x squared is equal to 8. And then I'm going to square root. So x is equal to, and I'm only going to take the positive value because we're working with lengths. We said that x was a length. So I'm going to say x is equal to square root of 8, which actually simplifies to 2 root 2. Because 8 was 4 times 2, square root of 4 is 2, and we have a root 2 left. So x is 2 root 2, and we have that twice here. And we need to find the length there. Okay, so what we can do is we can use the Pythagoras theorem to do that. So if I was to have square root of 2 root 2 squared add 2 root 2 squared. Okay, so this would be the length of the longer side. This then would simplify to, in this case, because I have 2 root 2 squared, that's the same as saying 2 root 2 times 2 root 2. Okay, so 2 root 2 times 2 root 2. So 2 root 2 times 2 root 2 like that. And I'm going to have that twice. Okay, so I'm going to have it again here. 2 root 2 times 2 root 2. Okay, remember with multiplication, because it's commutative, you can do them in any order. Okay, so this then becomes square root of, here 2 times 2 is 4. Root 2 times root 2 is 2, and 4 times 2 is 8. So I have 8 here, add another 8. That's going to give me square root of 16, which is 4, isn't it? 4. So this length here is 4. We know what the values for x are. Okay, it's 2 root 2. So to find the perimeter now, I'm going to do this, add that, add that. So it's going to be 2 root 2. Well, it's times 2, but I'll just write add 2 root 2. And then add a 4. And then this then becomes 4 root 2, add 4. Okay, and they said they wanted it in this form where a, b, and c are integers. So I'm going to write 4 plus 4 root 2. Okay, so question number 17. We have, on the 1st of January 2012, Beth invested some money in a bank account. The account pays 2.5% compound interest per year. And it says, on the 1st of January 2013, Beth withdrew £1,000 from the account. And then on the 1st of January 2014, she had £17,466 in the account. Work out how much money Beth originally invested in the account. Now, this is quite a complicated question. There's lots of calculations here. Okay, we have an invested amount. Then there was 2.5% applied to that. Okay, so from 2012 to 2013. And then 1,000 was withdrawn from that, and then another 2.5% applied to the remaining amount, and that took us to 2014, and the remaining amount was this. Okay, so what I'm going to try and do is I'm going to try and make an equation of what it's telling me, and let's see where we go. So we've got an initial amount. So we've got an initial amount, or let's say investment, for I for investment. If I times that by 1.025, that gives the amount that's left in the bank at the beginning of 1st of January 2013, before she withdrew. Okay, and then we can say she withdrew an amount. Okay, so then we can say take away 1,000. Here I wouldn't need brackets here because it's a multiplication, but I'm just going to put brackets anyway. So this, and then I'm going to take away 1,000. So once we've taken away 1,000, and then another 2.5% was applied to the remaining amount, which would be this much. And let's write that out. So there will be, this amount was then multiplied by 1.025. Okay, so take us to January 2014, and the amount that was in the account was 17,466. So this is equal to 17,466. Now, what I have here is I have an equation. Okay, I have an equation, I have one unknown, and I just need to rearrange this equation and solve it. Okay, so I can divide by 1.025, then I can add the 1,000, and then I can divide by 1.025 again. Okay, so what that would look like is, I'll say I is equal to, so it's this amount that I'm going to do it to. So I'm going to have 17466. I'm going to divide that by 1.025. Okay, so what I did was, because I'm timesing by 1.025 here, I'm dividing it here. Then the next stage would have been to add 1,000 to that. Okay, so then I need to add 1,000 here, and then so when I've added the 1,000, I'm just left with this part, and to get I on its own, I need to divide by 1.025 again. So I need to divide all of this amount by 1.025. Okay, and this should give me the value of the initial investment. Now let me just put that in a calculator. So we have 17,466 divided by 1.025, add 1,000, and then divide that by 1.025, and that is £17,600. So £17,600. Just to go over what I did here, I find it easy to do it this way. Okay, you might find it easier to do it in a different way, but here it's telling us a little story here, and then it has an end result, which meant, and it's telling me to find the originally invested amount, which I can represent with a letter. So I realized that I can make an equation and then rearrange it to solve it. Okay, and I did everything in sort of 2 steps here. Okay, you might want to use more steps, but this is the way that I find it easy, and you might want to learn to do it in this way. Okay, question 18 says the probability that Gina goes to the gym on Saturday is 0.9. The probability that Dave goes to the gym on Saturday is 0.6. These probabilities are independent. Now, what that's telling us is that the probability that both of this happens is the multiplication of it. Okay. Calculate the probability that both Gina and Dave go to the gym on Saturday. So we've already said that multiplying these will give us this probability. So we're going to have 0.9 times 0.6, and that's going to be 0.54. Okay, so 0.54. Question B. If Gina goes to the gym on Saturday, the probability that she goes on Sunday is 0.2. If Gina does not go to the gym on Saturday, the probability that she goes on Sunday is 0.7. And we need to calculate the probability that Gina goes to the gym on exactly one of the 2 days. So exactly one of the days, which means that she either goes on Saturday and does not go on Sunday, or that she does not go on Saturday and goes on Sunday. If they were to say at least one of the 2 days, then we would need to also add that she goes on both Saturday and Sunday. Okay. Now they've given us space here for us to draw a tree diagram, but we don't need to do that. Okay, we can think about the combinations that we're looking for. So we're looking for the probability that Gina goes to the gym. So goes to the gym on Saturday and does not go on Sunday. Add to that probability that she doesn't go on Saturday and she goes on Sunday. Okay. If you draw the tree diagram, okay, and then there'll be 2 branches that take you like that. Okay, and it does make it easier for you to see all the probabilities and calculate this correctly. But you don't need to. Okay, if you want to do it like this, you can as well. Okay, so the probability that she goes on Saturday is 0.9. Okay, it's up here. She goes on Saturday is 0.9. So 0.9 there. And she doesn't go on Sunday. So here, if Gina goes to the gym on Saturday, the probability that she goes on Sunday is 0.2. So that she goes on Sunday is 0.2. So she doesn't go has to be 0.8. So times that by 0.8, and we're going to add to that the probability that she didn't go on Saturday. So going on Saturday was 0.9, not going on Saturday would be 0.1, so 0.1 here. And if Gina does not go to the gym on Saturday, the probability that she goes on Sunday is 0.7. So not going and then going, so it's going to be times it by 0.7. Okay, and then we're just going to work that out. So this is going to be 0.72, add 0.07, and when you add that up, it's going to be 0.79. Now, I do recommend that you draw the tree diagram, okay, so that you don't miss any information. It helps you see how to do it, and it also helps you to find all the calculations. You see that this 0.8 is not here anywhere, okay, and this 0.1 as well, it's not here on this page. And if you were to draw the tree, you would have actually written them out, okay. So what it would have looked like is, so for Saturday, going on Saturday and then not going. Going was 0.9, not going was 0.1, okay. And then we're looking for going and not going here. So going and not going. So not going on Saturday. So it says not going on Saturday and then going on Sunday is 0.7. So it will be 0.7 here. Then you know this is 0.3, but we weren't interested in that one. Again, we're going to say not going and going. And here, once she's gone on Saturday, so if Gina goes to the gym on Saturday, the probability that she goes on Sunday is 0.2. So going again is 0.2. So 0.2 here, and then you can see the 0.8 is here. And the 2 sort of branches that we were looking for is that one, and the other one was through here and then through there. So we've got 0.9 times 0.8, that's what we have there. 0.1 times 0.7, that's what we have here. It's a lot easier to see from this, so make sure you are drawing this and you take your time to do that. Okay, so question 19, it says the height h meters of a particle at time t seconds is given by the function, and the function is here. Again, we can see that height has been plotted along here and t along there. So the height is 0 for t values from 0 to 2. Okay, so from 0 to 2, the height is 0, so it's just going to stay here. And then there's a different function for 2 to 10. Draw a graph to show the height of the particle in the first 10 seconds. So I need to go all the way up to 10. Now, you should recognize this as a quadratic function. Okay, so this is a quadratic function, so my points will not be joined with straight lines, it will be a curve. Okay, we can find some values. So if I was to put 2 in here, I would probably get 0, because here I can see that h is equal to 0 as it approaches 2. But it doesn't need to be like that. It's only in GCSE that this is most likely to be 0. You can assume that, okay? But later on, you can't. So if I was to put 2 in here, 14 take away 2 is 12. And then 12 times 2 take away 2 is 0. So 12 times 0 is 0. So it stays at 0. Okay, so there is a point here. I can mark that there. Let's try 3 now. 14 take away 3. So 14 take away 3 would be 11. And 3 take away 2 would be 1. So 11 times 1 is 11, isn't it? So 3 and 11. So we're going to have to plot a point there. Let's get a few more. So 4. So if I had 4, this time 14 take away 4. Okay, so I'm using the 4 value there. And 4 is in here. So 14 take away 4 is 10. 4 take away 2 is 2. 10 times 2 is 20. Okay, so 4 and 20 goes there. I'm going to skip some now. I'm going to go to 7 maybe. So 14 take away 7 is 7. 7 take away 2 is 5. 7 times 5 is 35. So 7 and 35 is here. Then we've got, let's try 10 now. 14 take away 10 is 4. 10 take away 2 is 8. 4 times 8 is 32. So 10 and 32. So it's going to be there. All right. And I can see that if I was to multiply this out, I would get a negative t squared. And a negative t squared would mean, actually, let me just multiply it out. What I would get is negative t squared. I will get plus 16t. And then I would get take away 28. Okay, that's what I would get. Now, in a quadratic function where the coefficient of the squared term is negative, the shape of the graph would be more like a N shape instead of a U shape. So this is going like that, and it will probably come back down if I was to carry on. So you have to draw a smooth curve through these points, and that's our graph. 19b now. By joining the points on the graph where t equals 3, so t equals 3 here, and that's my point, and t equals 7, so 7 is there, with a straight line, work out the average rate of change of height between 3 and 7 seconds. Now, I actually found the values here. Okay, so I know that the value here was 311, so this was 311, and this value here was 7 times 5 is 35, so it was 7 and 35. So if I was to draw a line here, a straight line, what I'm actually doing is, and then if I was to just find the gradient, so find the gradient of this line, that will give me the average rate of change. Okay, so the rate of change is another way of talking about gradient. Okay, so gradient of this line would be difference in y, 35 take away 11, divided by difference in x, 7 take away 3. So that's going to be 35 take away 11 over 7 take away 3. This will give us 24 over 4, which is equal to 6. Okay, so 6 meters per second. Okay, so question number 20, it says, in this question use 1 pound equals 0.4536 kilograms and 1 inch equals 2.54 centimeters. Here they're telling us the pressure of a basketball is 7.5 pounds per square inch. work out this pressure in grams per square centimeter. Now, pressure is normally force over area. So here we've got some kind of force, or grams here actually, or not grams, sorry, some mass per square inch. And we need to change the units, work out this pressure in grams per square centimeter. Okay. So if it was 7.5 pounds per square inch, what that actually means is I have 7.5 pounds per 1 inch. Okay, so I'm going to write it like that. Now, 1 inch, 1 inch is easy to convert here because we need it in square centimeters. Okay, so it's 2.54, so 1 inch. So here we're saying per square inch. Okay, so square inch would actually be 1 inch that way, 1 inch that way. Okay, so 1 inch and 1 inch. And therefore, that's the same as saying 2.54 on this side and 2.54 centimeters on this side and 2.54 centimeters on this side. Okay, so the size here, this square inch in centimeters squared is the multiplication of 2.54 times 2.54. Okay, so we'll put that in a calculator. So 2.54 times 2.54. It gives us 6.4516. So this square inch, actually, inch squared, I should have said. Okay, so this inch squared, I can change that now, and that is now, I can say 7.5 pounds per 6.4516. And this time I've got my unit in centimeters squared. Okay, so per square centimeter now. So to change that, I need to make it 1 centimeter squared at the bottom. So now what I have here is a fraction. So I would have to divide the bottom by 6.4516, and I have to divide the top by 6.4516. Okay, to get 1 centimeter square at the bottom. Okay, but I'm actually going to do that afterwards, because let's change the pounds into grams first. So here we know that 1 pound is 0.4536 kilograms, and that's actually, I'm going to put that in grams. I'm going to say that 1 pound is equal to 453.6 grams. Okay, because to take us from kilograms to grams is divided by, times by 1,000. Okay, so 453.6 grams. So to go from 1 pound to grams, it's this many grams. So 7.5 grams to here, I would have to multiply that by 7.5. Okay, so I'm going to put that in my calculator. So what I'm doing now is 7.5 times 453.6, and that will give me grams. So 7.5 times 453.6, that's 3,402. Okay, so this is equal to 3,402 grams. Okay, so now what I can say is I have 3,402 grams per 6.4516 centimeters squared. Okay, but remember, we want work out this pressure in grams per square centimeter. So 1 square centimeter has to be at the bottom. Okay, so if I divide, so here's a fraction. I can keep an equivalent fraction by multiplying top and bottom by the same thing, or dividing top and bottom by the same thing. So if I divide the bottom by 6.4516, I get 1, which is what I want, and I'd have to do the same to the top. Okay, so I'm going to do 3,402 divided by 6.4516. So 3,402 divided by 6.4516. That gives us the number 527.3 to 1 decimal place. Okay, so 1 decimal place is that. So therefore now I've got 527.3 per, so this is the number of grams, because the 3,402 was in grams, and this is now per centimeters squared, because this here was in centimeters squared. Okay, so our answer is 527.3. Okay, so question 21 says the speed of 50 vehicles was measured traveling along a road. Every driver traveling at more than 70 miles per hour is fined £60. So 70 miles an hour is here. On average, 8,400 drivers use the road each day. So it's not actually 50 cars, it's 8,400. Estimate the total amount of money raised from fines on the road each day. So 70 miles an hour. The reason why it's difficult is because we don't have we don't have this cutoff at 70, but we can see from 60 to 75 there's 15, and then 70 to 75 is 5. So it's about a third. Okay, so it's 5 out of the 15. So it's about a third of that. We can say a third of this 24 we can count as having got the fines. Okay, so we can say 1/3 of 24. We also need to add to that 9 and then add 4. Okay, so that will give us 1/3 of 24 is 8. 8 add 9 is 17, add 4 is 21, so 21. So we can say 21 out of the 50 cars got fines of £60 each. Okay, so if that was 21 out of 50, that's also a fraction, so we can use 21 out of 50. So if I use this sample for the 8,400, so times it by 8,400, so I'm finding this fraction of 8,400. So 21/50ths of 8,400. This is our estimated amount of fines there are. Okay, let's do that on a calculator. And times by 21. It's 3,528 fines. Each of them were £60. So 3,528 times 60 is equal to 211,680. So 211,680. So that's the estimated amount of money raised from fines from this road. Question B says, Mia says 4% of vehicles on the road travel at 40 miles per hour or less. Explain why she might be wrong. So in here we got 2 cars were traveling at 40 miles an hour or less. 2 out of 50. Now 2 out of 50 is actually 4%. Okay, but this is only 50 cars out of 8,400. Very small sample. So we can say that she has based her view on the whole population from a small sample. Okay, that's it. Okay, so question 22a says write x squared take away 10x add 29 in the form, this form here. Now this is the completed square form. What we do is we half this term and that number goes there. So what you do is you just have to remember how to do this. We have an x here, take away 5, because negative 5 is half of negative 10. Okay, and then we're going to square that, and we also need to take away a 5 squared. Okay, we need to take away a 5 squared and then add 29. That's going to be x take away 5 squared like this. We're going to take away 25, add 29, and in the end we're going to have x take away 5 squared plus 4. Okay, so this is just something that you need to learn. I'm not going to go over what all of this means yet. Okay, maybe something we're going to look at here, but otherwise you have to learn how to do this, and this is how it goes. Question 22b, a sketch of y equals a quadratic curve is shown. The turning point is 3, 5. Okay, now when you complete the square, you can actually get the turning point. If this was y equals this, the turning point for it would be 5 and negative 4. 5 and 4, sorry. Okay, so it's the negative of this, so it's going to be 5, and it's going to be this value here, which is 4. Okay, and we can think about why that is in the lessons. Okay, so in this case, we know that this graph is y equals x take away 3 squared add 5. Okay, and the question is work out the values of c and d. So find these values here, multiply this out, make it look like that, and then we can find it. Okay, so x take away 3 times x take away 3, and I need to add 5 at the end. This is going to be x squared take away 3x take away 3x plus 9 add 5. Then we're going to have x squared take away 6x add 14. Okay, so c is -6 and d is 14. Okay, so question 23, we have two triangular lawns are shown. Okay, so it's here. Wire fencing is needed for all 5 sides, and they've put that 5 in bold. So it's not just the perimeter that needs wire fencing, also this length here. So there's 1, 2, 3, 4, and then 5. Wire fencing is sold in 50-meter rolls. Work out the number of rolls needed. Okay, so this is something that we might use towards the end of our working out. Okay, so I can see that I have triangles, I'm working with angles, I'm working with lengths. Therefore, I probably am going to be using trigonometry here. Now I need to think about what kind of triangles I have. I have a right angle triangle here. Now I can use some very basic trigonometry for this. Okay, SOHCAHTOA you might be thinking about. That's what I'm going to use to find this length and this length. When I know this length, I've got this length and I've got a 30 degrees there. This is not a 90-degree triangle, so I would have to use either sine rule or cosine rule. I need to think about which one I need to use to find this length here. Okay, so let's do the easy part first. Let's find this length and let's find this length. Now, we'll go with this length first. Now, this length is the adjacent side to the 40 degrees. So cos 40 would be this length divided by 100. Okay, so I'll give them some names. So let's say x here, y there, and I'll call this one z. Okay, so cos 40 is equal to x over 100. Therefore, x is equal to 100 times cos 40. Now, I'm not going to put this in my calculator now. It's very tempting to do that. But what I'll end up doing, guys, is I'll be rounding it, and then I'll lose some accuracy towards the end. Okay, so I'm going to keep it like this for now. I know that x is equal to this, and this will give me a number. Y, now, so y is the opposite length of the 40 degrees. Okay, so here I'm going to use sine 40. Sine 40 is equal to y over the hypotenuse. Okay, so y over 100. So sine 40 is equal to y over 100. Okay, therefore y is equal to 100 times sine 40. Okay, so that's x and y. I've got values for these now. I might want to write that in. So x is equal to 100 times cos 40, and y is equal to 100 times sine 40. Okay, remember, we're not putting this in our calculator now because we'll end up rounding it, and then we'll use rounded values for other working out that we're going to do, and we're going to lose some accuracy. Okay, so we're going to keep it like this for now. So now I can think about this triangle. Okay, a bit more complicated now. It's not a 90-degree triangle, so I'm going to have to use the sine rule or the cosine rule. I can see that I'm going to be using the cosine rule. Okay, so I'm working with one angle, and I've got 3 lengths that I'm working with. Okay, so notice what I'm saying. I'm saying that I'm working with not what I have. Okay, I have 2 lengths and an angle, but I'm saying that I'm working with 3 lengths and 1 angle. So 3 lengths and 1 angle. When I'm working with that, that's the cosine rule that I need to be working with. Okay, so cosine rule would be this length squared is equal to some stuff which I'm going to be writing here. Okay, so let's write that down now. So we're going to say z squared is equal to, it's going to be y squared plus this squared, take away 2 times y times this, times cos of 30. Okay, so I'm going to write that down now. So we're going to have 100 sine 40, which is y. Okay, so this is my y. I'm going to square that. And I'm going to add to that 120 and square that. Then I'm going to take away 2 times 100 sine 40 times 120, okay, and then cos of 30. Okay, so that's what I have. Now, you might think of this like a squared here, so a squared equals b squared plus c squared, take away 2 times b times c times cos of capital A. Okay, so that's what we have here. You can see that I can have one value for this, but that won't give me z, that will give me z squared. So if I was to square root that, that would give me z, okay? So I'm not going to write that here, but when I put it in my calculator, I'm going to do it. Actually, I'm going to write it in. Okay, so it's going to be square root of everything that I've written there. So z is equal to 100 sine 40 squared, add 120 squared, take away 2 times 100 sine 40 times 120 times cos 30. Okay, so that will give me my z. What I'm going to do now is I'm actually going to calculate some values, okay, and then I'm going to add. Okay, so I'm thinking about the wire fencing is sold in 50-meter rolls. So I need to find the lengths. So I need to find z, y, and x, and then I'm going to divide that by 50, okay? But when I calculate these, okay, so when I calculate these, I will be writing my answers to maybe 4 or 5 decimal places, okay? And then in the end, I'm going to round it maybe to 2 decimal places, okay? So I will try and keep it a little bit more accurate when I've got these values, and then in the end, I'm going to go 2 decimal places, okay? So x, I'm going to put that in my calculator now, 100 times cos of 40, that gives me 76. So this is equal to 76 point, let's say 60444. Okay, so this is to 5 decimal places here. So this is to 5 decimal places. Let's get y. Y is 100 times sine 40. And that gives me 64.27876 to 5 decimal places. Okay, so I've got a value for x, and remember these are in meters. Okay, so we're going to say meters and meters. Now I'm going to put all of this into my calculator to get the value for z. Okay, so I'm going to start with the square root, and then I have 100 sine 40, and I'm squaring that. Then I have add 120 squared, take away 2 times 100 sine 40, times that by 120, and times that by cos 30. Okay, and that is what I'm square rooting. And that gives me 71.91432, and this is to 5 decimal places. Okay, so this is in meters. So now I just finish off my question. So I've got a value for x in meters, value for y in meters, value for z in meters. I need to add it to the 100 and the 120, okay, and then divide that by 50. Okay, so I'm going to do the addition first. I'm going to say 100, add 120, add 76.60444, add 64.2787, add 71.91432, and I'm going to divide all of this by 50, okay? Because the question is, wire fencing is sold in 50-meter rolls, how many rolls will be needed, okay? So if I would need to divide that by 50, let's put that in my calculator. So we have 100, add 120, add 76.60444, add 64.2787, I didn't put the 6, 27876 I'm going to use, add, so 6 here, add 71.91432, and I'm dividing all of that by 50. Okay, so it's going to be 8.65595504. But if I divide it by 50 and I got this answer, then I will need 9. 8 won't be enough. I will need a little bit more, so I'm going to need 9 rows. Okay, and I'll have a little bit of spare. So 9 is the answer. Okay, so question number 24. The community frequency diagram shows the times taken by runners to complete a half marathon. So I can see that there are 120 people's times recorded here. And it tells us on the grid opposite, draw a histogram to represent the data. Use this table to help you. Now, or use these tables to help you. Now, I can fill this in because that comes from the community frequency diagram. We normally have a table like this and we draw a community frequency diagram. This time we have to sort of work backwards from that. So we look at how many people scored a time less than 100. That's here, which is 8. Okay, so that's 8. Next one, we look at how many people did less than 120. So that's going to be there, which is 56. Next one is less than 160, which is up here, which is 100. And less than 200, we have 110. And less than 300, we already know it's going to be 120 because we've seen that already. Okay. Now, remember, these are community frequencies. And now they've broken them down into different intervals, and I need to find the actual frequency for each interval. Okay, so less than 100, or between 80 and 100, I know that there were 8 people, and it's telling me here as well. Okay, now you must remember that this 56 is made by 8 add whatever that is, because everyone that did less than 120 did more 80 or more and less than 120. So everything between 80 and 120 needs to add up to 56. So this must be 48. Okay, so 48, because 48 add 8 gives us 56. Next one, now I need something here that will add to these and make 100. Okay, so that would be 52. That would be, let's see, 48 add 8 is 56. There were another 44 people. Okay, so 44 people. Not 52, okay, so because it's from 56 to 100. Now 100 to 110 is 10, and 110 to 120 is also 10. Now, class width. Now, in the previous test where you had to do a histogram, they didn't give you this column, and here they've actually helped us out by saying this is something that we need to think about. So class width, 80 to 100 is 20, okay, so 20. 100 to 120 is also 20. This time, 120 to 160 is actually 40. Okay, so 40. 160 to 200 is also 40. And 200 to 300, so we've got 200 to 300, that's 100 in between. Yeah, so 100 here. Now, histograms, best way to think about histograms is the frequency density and the class width should multiply to give you frequency. Okay, so that's how we do it in GCSE Maths. So if these two need to multiply to give you the frequency, then surely the frequency divided by that will give you this. Okay, so to find that, what you do is you do 8 divided by 20, and that's going to give us 0.4. Then we've got 48 divided by 20. That gives us 2.4. 44 divided by 40 this time is 1.1. 10 divided by 40 is a quarter, which is 0.25. And 10 over 100 is 1 over 10, which is 0.1. Now I can see my frequency density goes up to 2.4. So I need this to maybe go up to about 3. Okay, so let's count the boxes and see how to scale it. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 boxes. 14 boxes. So I don't need to go all the way up to 3 because it's 2.4 will be enough. So if I've got 14 boxes, I'm going to do 5 for 1, and then when I get to the 10th one, that's going to be 2. So let's do that. 1, 2, 3, 4, 5. That's 1 here. 1, 2, 3, 4, 5. That's 2 there. Okay, and now I can scale it up. So I've got 0.2, 0.4, 0.6, 0.8. Okay, I'm not going to write all of them. I'm going to write these ones though, 2.2 and 2.4, because that's as high as I'm going to go. Actually, I'm going to write them in 1.2, 1.4, 1.6, and 1.8. Okay. Now, we've got between 80 and 100. So between 80 and 100, I need to go up 0.4. Okay. So you need to use a ruler and a pencil for this. Okay. We need to go to 0.4 from 80 to 100. Okay. Next one is from 100 to 120, and this one goes all the way up to 2.4. Okay, so all the way up to 2.4 now. So we're going to go all the way up. And this one went up to 120, so it's going to be here. Okay, so that's that one. Next one is 120 to 160, and that goes up to 1.1. Okay, so 1.1 would be here, and that goes to 160. Okay, so line going from here. Next one I'm looking at is from 160 to 200 here. Okay, and that needs to go up to 0.25. 160 to 200. So 0.25, 0.3 would be in the middle there, so 0.25 around here. Okay, so 0.25 is about there, and that needs to go up to about 200, or up to 200. Okay, so that's that one done. And the last one, from 200 to 300, is 0.1. Okay, so 0.1, and that's all the way through here and down. Okay, and you can see that because in a histogram the areas represent the frequency, you can sort of see the distribution where everything is. So there's a sharp concentration here, lots of people here, quite a lot of people here because that's got more thickness. Okay, and then you can see it sort of tails off at the end, and that's our histogram done.